Hello, welcome back. So in the last problem, we have visited a couple of important things. The first thing is that to determine how much a function has been shifted, okay, from its original version. So we mentioned that the shifting amount should not be like the one that directly inside this pair of parentheses. Instead, you need to look at the amount that is added or subtracted to the variable of interest. Okay, so you need to take out this 2 in this case in front of t. So this is the amount of shifting to the right by a quarter. And then we also discussed that, so for the convolution problem, how can we look at discuss the subintervals? At least you need to figure out what it looks like for the flipped and slided function. Okay, so this is a flipping process, and this slide to the right process by a step tau. And then you need to figure out those values, how those values are going to be compared with this 0.5 here, right? So you ended up 1, 2, 3, 4, 5 different cases, right? For each case, you are going to discuss the overlapping area here, overlapping interval. Okay, so the idea is that you need the right edge of this rectangle to be on the left-hand side of this black rectangle. Okay, so you have inequalities, you have the intervals. Once you get these intervals, you need to determine the integration limits, which the limits is here 0 to t plus half, right? You just copy them if you have them already on the graph, right? And finally, you put everything together. It's easier for the TA to grade, right? So now let's look at the other problem. So we have two things. Let's draw them separately. And so first one is what? It's a function. Here is from negative 3 to positive to 0, you have value of 1. And for all other locations, you have value of 0. Okay, of course, it's scaled by a scaling factor e to the 4th. Okay, so this is a constant, e to the 4th. Okay, it's not e to the 4t. Okay, so that's right. The horizontal axis t. Okay, so there's x of t. And the other function is h of t. H of t is an exponential decaying function e to the minus 3t, but multiplied by a rectangular window that has values between 0 and 1, right? Between 0 and 1, it is 1, or other places it's 0. So essentially, you just have one segment of your exponential decaying function. Say this is 1, this is 2, and essentially you have values here, right? And then you have 0 here and 0 here. Okay, so this is what we have before we even get started. Now, if you want to do the convolution between this and this, and you need to decide which one to flip, right? So the rule of thumb is that we are going to flip a function that has a simpler form. So after flipping, it will become a little bit more complicated, while the other one is already a little bit complicated, but neither of them are too complicated. Okay, so let's write it. So we have y of t is, we want to flip one of them. So we want to flip this guy. So we will let this guy stay the same. So staying the same, the term will be in the front. Okay. And by using the definition of integration, the first term, you just copy it, replace t by tau. Second one, you replace t by minus t by t minus tau, right? D tau. And integration bound is r for now. Okay, so let's take a look. What's going on? Okay, so we are going to have, so this one is just in the same figure, right? And then you're going to replace t by tau. So let me, don't do it now, okay? But later we will do it. So here is xt minus tau. Okay, so it's going to be a flipped and the shifted version, right? Note that now it's this function we are interested in is a function of tau now. Okay, so let's do it. So as we have mentioned before, so this function can be written as negative tau subtract by t. So you can consider obtaining this function by first getting first you have x of tau function, right? And then you are going to get your flipped version x negative tau, right? And then the third step is that you move to the right by t steps. So this is the chain of operation, right? Can get you a graphical illustration of what is xt minus tau. Okay, so let's do it. So x tau, right, is just this one, right? And x minus tau is a flipped version of it. So the 0 here is 3, right? And then finally shift to the right by t steps. So here is 3 plus t, because 3 shift to the right by t. I say t is 1, so that's 4. Okay, here this point is t. Right, so this is what you have. So after this 1, 2, 3 steps, you get this function, right? It's actually this function. So I just write it xt minus tau. Okay, and then maybe I put things here. Things here. Right. Right, and then I probably want to erase this because I used this expression too many times. Okay. Right, so now let's move on. So you have integration task, which you multiply this h of tau with the xt minus tau. H of tau is the thing. Ht minus tau is the thing. You're going to multiply these two together. You can see that, so this guy, if I'm sitting on the left-hand side of this exponential decaying segment, and then we have 0 overlap. If this guy is on the right-hand side, and we have 0 overlap. And then difficulty here is, so this width is actually 3, right? From here to here, 3. From here to here, the width is 3. Why? Because 0 minus negative 3, so that's the width of 3, right? Or 3t minus t, that's 3. Right, so, and then there are complicated conditions that this one is overlapping with the left-hand side, left part of this one, or overlapping with the right part of this one, or because the width is 3, so this can completely overlap with the 0, 1 to 2, right? So there are many different cases. So let's discuss them one by one, right? So let's use the backing. 1, 2. Here, tau. This is my function h of t, but I call it h of tau. Okay, and then the window function, I can put it here, right? So there's a t plus 3, right? And in this case, we have no overlap. So this is the first scenario, have t plus 3 less than 1. Which leads to t less than, right? Okay, so doing this problem, I will do it like completely for each subinterval, and then I will continue one by one for those intervals. Okay, so the steps will be different from I do it for the last one. It's y of t is like an integration from negative infinity to positive infinity, and then the first function is h of tau is here, right? So this is xt minus tau. Let me write it. Xt minus tau. So h of tau is here. Okay, so h of tau is not 0, but you multiply with a 0 here, so you get a 0. And for this segment, right? So xt minus tau is not 0, but h of tau is 0, right? Everybody is 0. 0. So it's actually 0. Okay. And now let's look at another scenario. We do it one by one. tau 1, 2. And we have note this red one is actually wider, right? So this length width is 3. So in this case, our overlapping segment, let me use the overlapping segment is here, right? From 1 to t plus 3. So all other places, here we only have one curve, the other curve 0. Here we have just one curve, which is here. Right? Here we have no curves here. So basically, only this interval gives you non-zero integration values. So we can have the limits. Let's take a look. So this t minus 3, to the best, it should be not exceeding 2, right? Or t minus 3, at least it should be greater than or equal to 1, right? So that will make the left part of this black function being overlapped with the right part of the red function. Okay? So we write 1 less than t plus 3 less than 2, right? Because this, right? Okay, now we have t must be less than -1, greater than -2, right? So this is another interval. So in this case, y of t is going to be an integration, okay, of two functions. The first function is what? The first function is h of tau. H of tau is this one. So this one, h of tau. So what's the expression for it? So it's e to the minus 3t. Okay, e to the minus 3t. E to the minus 3t. And the other function is unit step function multiplied by a scaling factor e to the 4. Okay, it's constant e to the 4. Okay, the tau, and the integration range is from 1 to t plus 3. So we get, and this is a constant, we can take it out. And this is integration with respect to exponential function, right? Apply the chain rule, you will obtain e to the negative 3t. You pull down this 3. Okay, so that's applying the chain rule, and then you have e to the 4 in the front. It's not involved in the integration, and here ranges from 1 to t plus 3. Right? And then once you have that, you need to plug in things. Let's see, it's -3, negative e to the 4 over 3, and then you have e to the negative 3, t plus 3, minus e to the negative 3 times 1. Right? So yeah, and then you can simplify. Okay, so let's look at another interval. As you move your interval to the right and the red interval to the right, and all of a sudden, right, your whole interval, red interval, is covering completely this black interval, right? This black is here, 1 and 2. So for this case, right, the constraint is that t must be always on the right-hand side, on the left-hand side of 1, right? And this 2 must be on the left of t plus 3. So you have less than, right? So you have t, you have two conditions, t less than 1, right? And the other is 2 less than t plus 3. So, and the total, put them together, you have t less than 1, greater than negative, right? And then in this case, your yt, the integration limit is from 1 to 2, right? So this is a complete interval. So let's say it's 1 to 2, and the first function e to the negative 3t, that's the exponential decaying function, e to the 4 d tau, right? So here, the internal part is exactly the same, except the integration upper and lower limits, right? So here it will become 1 and 2 here, okay? So what do we have? have negative e to the 4 divided by 3, and then e to the negative 3 times 2, x minus e to the negative 3, right? And then you can further simplify it. Okay, so let's continue. So we further move the red interval to the right, and then we will have the left part of the red interval is overlapping with the right part of the black interval, right? Again, you can see that if you want this condition to hold, we have a couple of things to see. Probably the t should not go on the left-hand side of 1, right? So this is the best you can go. And this t should, this edge can only go up to 2, right? So you are going to bound your t by this 1 to 2. Okay? So in this case, okay, so we have partial overlap on the right side of the black interval. Okay? So y of t is actually integration from now, from t to 2, right? From t to 2, why? Because from here to here, that's our interval. Okay, so everything is the same here, and then 3 e to the 4, and then here we have e to the negative. Look at this one, so from t to 2. Okay, so this 2, so this one. Okay, let's see. So e to the negative 6 subtracted by e to the negative 3t. Okay, and then you can further simplify. Okay, so let's go further. Yeah, so that will be the last one once you move the interval outside. Once you move the red interval outside the range of 0 and 2, 1 to 2, then you get no overlap at all. So here, this point is what? This point is t, right? You just need t greater than 2. That's what we have. And the integration is going to be on R, but everyone will be 0, right? So the outcome will be 0. Right, so now it completes 5 scenarios, and then you can look at what are our integration limits, right? Less than 2, negative 2, negative 2 to negative 1, negative 1 to 1, and then 1 to 2, the t greater than 2, right? And then you will, as I said, we want to have a good habit, put everything together. So let's copy the interval from the bottom to top, greater than 2, t from 1 to 2, and the t from negative 1 to positive 1, and the t from negative 2 to negative 1, and the t less than negative 2. And yeah, I can move it a little bit to like better. Right, and then you put results here. Okay, and then what are these results? And let me copy them here. It's e to over 3 minus e negative 3 t minus 5 divided by 3. Okay. Second one is e over 3 subtract by 1 over 3 e squared. And here is e to the 4 over 3 e to the negative 3t subtract by 1 over 3 e to the square. Okay, e squared. Okay, so that's completes this problem. Okay. I'll stop here.